Hello and welcome everyone. In this video, we'll go over a MATLAB code for handwriting recognition with deep neural network. But first, we will need a digit dataset which consists of 10,000 synthetic grayscale images of handwritten digits. So this can be found using this link. Or you can find it through the local disk. Local disk C, Program Files, MATLAB, R2023B, Toolbox, scroll down for NNet, NN Demos, NN Datasets, and then on the digit dataset. Each digit has 1,000 images in respective folders and has a 28 by 28 pixel size. I would also love to give credits to the YouTube channel Exploring Technologies for helping me with this activity. You can visit them with this link. Let us start with the MATLAB code. So first we need to define the dataset path. You can copy this as path and then paste it on the code later. So I have named the folder digit dataset. So next, we are gonna set up the image storage and labeling. So we set the parameter IncludeSubfolders to true, and that ensures MATLAB will search within all subfolders in digit dataset and automatically label images based on folder names. So next, we have to split data for training and testing. So you can just use all of the data or you can split it. So in my case, I have split it 75% for training and the remaining 25% for testing. So define the number of training files with numTrainFiles representing 75 of the images per folder. And alternatively, numTrainFiles can be defined as a percentage, which can be given as 0.7. Next, we have creating the CNN layers, or the convolutional neural network layers. So first, we have the input layer, which is, you can see here, is a 28-28-1. So it means it has a 28 by 28 pixel, which is a grayscale image. Then, we have the convolutional layer. The first convolutional layer applies 3 by 3 filters, as you can see, it's 3, with 8 filters and same padding. The batch normalization and ReLU layers, this help to normalize and activate the output from the convolutional layer. Next is the max pooling layer, which uses the 2 by 2 filter with a stride of 2, reducing the output size. In the following layers, we increase the numbers of filters, which is 8, 16, 32, and 64, to add complexity to the network, enhancing its ability to recognize patterns. And this patterns of layers is repeated with higher neuron counts. For the final layers, the last max pooling layer is omitted, and we added 3 essential layers, which is the fully connected layer, which matches the number of categories or digits, the softmax layer for classification of probabilities, and the classification layer, which assigns each image to a digit. To view the structure graphically, we use the layer graph or the L graph to plot the commands. These commands display the network structure visually. We will see that later. Next, we have training options and execution. So the solver is the SGDM, which is a stochastic gradient descent with the momentum. We have initial learning rate of 0.01. We have max epochs of 4, shuffle data, which enable for each epoch, validation data, which is the TestImages, validation frequency, which is customizable, I just put here 30, plot training progress, which is enabled to show a training progress plot. Once defined, start the training with the train network function, which will create a trained model using training images, layer configuration, and training options. Next, we have classification and accuracy calculation. So after training, use the classify function with net and test images to make predictions. calculate accuracy by comparing the predicted labels to actual labels. This shows the model's performance in percentage. So now I'm going to click Run to start the training. So as we can see, the training process will display a graphical plot of training progress, showing loss and validation accuracy as the epochs progress. So as we can see here, the accuracy increases whilst the loss decreases. So we have a validation accuracy of 99.68%, and the training is finished with a max epochs completed and with lapse time of 29 seconds. 4 epochs, 232 iterations, frequency of 30 iterations, and a single GPU. You can see these times we have the training, smooth training, and the validation. Next, we are gonna test with custom images. So let us open the MS Paint or any image editor and create a new image with dimensions 28 by 28 pixels. Let's fill the background with black and write a digit in white. I will use a 2 pixel size marker and write the number 7. And then we have to save this image as a BMP file, ensuring it's saved in grayscale by selecting 256 BMP. Okay, let's go back to MATLAB. So selecting an image for testing, we begin by using the UIGetFile function, which opens a Windows dialog box to let you select a file. Once an image is chosen, it's loaded into MATLAB and stored in a variable I. The IamShowI is to display the selected image. The recognized label is displayed as a title on the image, showing whether the image was correctly identified, and that I will label it as recognized digit is. So let's run it and select the image we did earlier. So as you can see, it recognized the digit is 7. So it is accurate. Okay, let us try again with another example. But this time, I will write the number 8. And still save it in a BMP picture. Let's name this test 2 and then save. Okay, let's run it again. And it recognized the digit as 8. So again, it is correct and accurate. This code allows you to test the model with both dataset images and custom images. I hope you learned something from me. Thank you and good night.